Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed about the binary semaphore. I hope you have watched that video. If you did not watch that video or if you don't know what is a binary semaphore, I request you to go back and watch that video and come back to this video. In this video, I want to discuss one of the gate question which came in the year 1997 related to binary semaphore. This kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. Each process Pi where I is equal to 1 to 9 is coded as follow. So this is the code for the process P1 to P9. Look at the code. Repeat P mutex critical session V mutex forever. Now the code for process P10 is repeat V mutex critical session V mutex forever. What is the largest number of process that can be inside the critical session at any moment? They are given 4 options. Option A is 1, option B is 2, option C is 3, option D is none of the above. We need to solve the question and find out what is the right answer. If you look at, they have given P mutex. Maybe you don't know what is these two things. See, already in the last video, I have discussed the down operation. Is it clear? Whenever a process wants to enter into the critical session, it will perform the down operation. So we can call it as a down operation or P operation or wait operation. Similarly, whenever a process wants to leave the critical session, it will perform the up operation, V operation or signal operation. Is it clear? So I hope you have understood what is the P operation and what is the V operation. P operation is the down operation, V operation is the up operation. Now mutex is nothing but the binary semaphore. Is it clear? We can call it as a mutex or the binary semaphore. Look at this one. The process P1 wants to enter into the critical session. If the process P1 wants to enter into the critical session, it has to execute this code. Now what is this one? Down operation on the mutex. Is it clear? Usually you know that mutex value or the binary semaphore value, initially we will keep it as 1. Okay, let me keep it mutex is equal to 1. Okay, now process P1 is performing the down operation. What is the code for the down operation in the binary semaphore? Let me write the code for you. Down, okay, semaphore yes. Is it clear? If s dot value is equal to 1, we will keep the s dot value is equal to 0. Else, put the process PCB in queue, okay, sleep. Am I right or wrong? This is the code for the down operation. Now look at here. Process P1 is performing the down operation. Now s dot value, yes, mutex value is equal to 1. The condition is true. If the condition is true, it will keep the mutex value is equal to 0 and enters into the critical session. Now look at here. Let me erase this part. Okay, I hope you can understand this one. So process P1 is entered into the critical session. Let me keep it as CS, which is a critical session. Inside the critical session right now, process P1 is there. Now look at here. Process P2 wants to enter into the critical session. If process P2 wants to enter into the critical session, it has to execute this code. What is the first operation? Down operation. Now down operation, if you know the code properly, already I have written here. Now if mutex value is equal to 0, now when the process P1 enters into the critical session, it will keep the mutex value is equal to 0 and enters it. That's what, if mutex value is equal to 1, it will keep the value is equal to 0 and enters into the critical session. Now process P2 wants to perform the down operation. Now the if condition will be false because mutex value is equal to 0, 0 is not equal to 1, so it will execute the else part. Okay, in the else part what is there? Put the process PCB in the queue. Okay, so as the critical session is being occupied by the process P1, process P2 will go to the sleep state or wait state. Is it clear? Similarly, let's take that process P3 wants to enter into the critical session. If process P3 wants to enter into the critical session, again it will execute this code. What is the first part? Down operation. Now mutex value is equal to 0. So the if condition will be false. Again the else one will be executed. What is the else? Process P3 will keep it in the queue and it will go to the sleep state. Like that, process P4 wants to enter into the critical session, again it will be blocked. Process P5 wants to enter into the critical session, it will be blocked. Like that, up to process P9 will be blocked. Are you able to understand? They are in the waiting state. Is it clear? Now let's take that process P10 wants to enter into the critical session. What is its code? Repeat up operation. Here it is a down operation, but here it has to perform the up operation. Now look at here. What is the up operation code? Is it clear? If you can remember it correctly, let me erase this one. This is critical session. I think you can understand. Okay, now up operation code is what? Up. Okay, now if q is empty, then semaphore value will be keep it as 1. Let me keep it as mutex value will be keep it as 1, else the process has to wake up one process from the PCB. So it will select a process. Let me write it like this. Select a process from PCB and wake up it. Okay, wake up it means it will be scheduled to the ready state. Is it clear? Are you able to understand? So look at here. This is the code for the up operation. So process P10 is performing the up operation. So Q is empty? No. There are 9 processes from P2 to P9. Not 9. 8 processes are there in the queue. So Q is not empty. If the queue is not empty, else part will be executed. Select a process from PCB. Let's take that. This one I am implementing using a queue, and you know that queue will use the principle called first in first out. Meaning is that the process which was entered into the queue first, that will be deleted or removed first. So process P2 will be removed and it will be wake up. Is it clear? Are you able to understand? So once it will wake up, as it has performed the down operation, after that one there is a critical session. So process P2 will enter into the critical session. Now similarly look at here. Process P10 has successfully executed the up operation. So it has completed this one. After the up operation, what is their critical session? So process P10 also enters into the critical session. Whereas for the process P1, after the up operation it is leaving. But here after the up operation there is a next code called critical session. So as it is completely executed, it will execute the critical session. So right now process P1, process P2, process P10 are there in the critical session. Now let's take that. Process P10 wants to leave the critical session. When it is leaving the critical session, what operation it has to perform? Again it has to perform the up operation. Now look at here, process P10 wants to leave the critical session, so it has to perform the up operation. Now again in the up operation, is queue is empty? No. The process from P3 to P9 are there in the queue, so queue is not empty. So select a process from the PCB, okay, and wake up it. So once it wake up, it will go to the ready state. Once it dispatch to the running state, it will go to the critical session. So now process P3 entered into the critical session. Now what actually it is doing? Once the process P10 executes its code, it is wake uping 2 processes which are there in the queue. Am I right or wrong? Once here, once here. Let's take that. Again process P10 is running its own code because it is a repeat. Are you able to understand it or not? This is repeat forever. So again process P10 is executing its own code. Then what is it? Up operation. So if up operation queue is not empty, so it will wake up the process P4. process P4 will enter into the critical session, then process P10 will enter into the critical session. Once the process P10 leaves the critical session, again it will perform the up operation. Now Q is not empty. Is it clear? Because P5 to P9 process are there, so else part will be executed. Process P5 will enter into the critical session and process P10 will leave the critical session. Basically right now P1 to P5 process are there. Now let's take that again process P10 is running its own code. Now process P6 will enter into the critical session. Process P10 also will enter into the critical session. While it is leaving, process P7 will enter into the critical session. Now let's take that again process P10 is running its code. Then this time process P8 will be bringed into the critical session, and then process P10 will enter into the critical session. While it is leaving, it will wake up the process P9 and process P9 will enter into the critical session. Now let's take that again process P10 is running its own code. Now if process P10 is running its code, now look at here, again it is performing the up operation. So Q is empty. Yes, Q is empty. Mutex value it will keep it as 1. Okay, mutex value it will keep it as 1 and it will enter into the critical session. So how many processes are there at max? That is what they are asking. What is the largest number of processes that can be inside? Now how many processes are there from P1 to P10? So how many processes? P1, P2, P3, 4, 7, 10 processes are there in the critical session at max. Now look at the options. Option A is 1 is wrong. Option B is 2 wrong. Option C 3 is wrong. Option D none of the above. So this is the correct answer for this question. I hope you have understood how I solved this question. If you still have any doubts related to this question, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.